And anybody know what is the role of the food systems? That means all agriculture. Agriculture means crops, trees, livestock, fish, etc. Agriculture broadly, that means the food production, then consumption, wastage. It's called the food system, right? So you know the contribution of the food system in climate change? I'm not going to theory, I'm just saying, do you know what is the weightage of that in the greenhouse gas emissions? Ah, okay. It is the single largest cause of climate change. 34% is on account of the food system, entire food system. That means not only the way in which we are producing food, transportation, consumption, and wastage. A lot of food is wasted. I hope you are aware of that. Okay. Then is there a way out of the climate crisis? What happened? Ah. No, I didn't mean food waste. I'm saying, is there a way out of the climate crisis? So I didn't see that kind of enthusiasm saying that, yeah, we'll overcome, right? Okay, so maybe I'll ask the question at the end of the session. Right, but please, yes, so it's clear that it's a very, very serious issue and something, the role of agriculture in this whole crisis has been very severely underestimated. Our entire focus was on reducing emissions. Okay, one or two final questions. You all know about greenhouse gases, right? So when I say greenhouse gas, what comes to your mind as what is a greenhouse gas? Carbon dioxide. Methane, okay. Oh, yeah. But none of you told me water vapor. 80% of the greenhouse gas is water vapor. Then global warming. What is the most important factor for global warming? 95% is on account of heat re-radiated from water vapor. All other gases, whatever you mentioned, account for less than 5%. Carbon dioxide levels right now are around 427 parts per million. So pre-industrial era was 280 parts per million, and scientists, experts said 350 parts per million is a, no, that's a limit we should not cross, but we already crossed it. But you won't die even if CO2 levels cross 1000. But you will die of floods, die of droughts, cyclones. So the water cycle is totally out of gear. And you also heard Bangalore, no water. I don't know about many other cities, many countries, no water. So the water cycle, what we do with the soil, it's all very intimately connected to climate change. So I'll take you through is what we are doing in Andhra Pradesh. And initially we started this as a solution to farmers' livelihoods. You're all aware of the crisis of farmers, distress, farmers' distress? Any of the young people want to do farming? Not you, I'm talking about rural youth, let us say, right? They are running away. So the average age of farmers is 50 in India. So there is a demographic crisis. So there's very serious farmers' distress because every year their cost of cultivation is going up and riskiness of the crop is increasing. They don't know whether they'll get it, whether it will rain, not rain, or rain more when it should not rain. And we also don't know what happens when it goes to the market. There's a very serious problem of tenants. Conditions of tenants are very, very bad. So there is very acute distress of farmers, and you're already seeing there's so many agitations in different states and also in different countries across the world. So there is a very serious farmers' distress. Secondly, we're all consumers, right? So do you think we are consuming good food? No. Yeah, you're right. We're not consuming good food. Huh? One, the food you're consuming has lots of chemical residues. But second, more important, which you may not be aware, is the food produced now is less nutritious than it was 60 years ago. Some studies recently from National Institute of Nutrition. There is a study from UK where they compared all the foods 1941 and 90, so 50 years, 50 years gap. And this study itself is 30 years old. So they said all the foods they studied, the level of every nutrient has declined from 10% to 100%. That means some micronutrients which were there in the foods previously are no longer there. So that's why suddenly during COVID you discover what is it, magnesium, zinc and all these things. We never heard of this, isn't it? Suddenly you find you don't have that and there's a serious health problem. It should have been in the food you eat. So it's not there in the food. So that means the food that we are eating are not nutrition dense. They are not having the balance, what the kind of micronutrients and minerals that should be there. There's another third problem. Rice, for instance. I don't know anybody from Bengal here? Bengal. So, Odisha and Andhra. A lot of rice there has arsenic. Are you aware of that? Arsenic, lead, cadmium. So there are heavy metals in the rice that we are eating. That means the food we are eating is not contributing to our health. So sometime in 2016, I think globally there was a study which said the disease burden on account of food has crossed 50%. So the food is eating is basically the cause of your health problem. So consumers are not happy. There is a serious problem with on the consumption side. And third, we know very well there is a water crisis. There is a soil emergency. India, for instance, has 16% of the world's population, but we have only 4% of the world's fresh water supply. Similar in terms of soil, the rate at which we are losing soil, the rate at which India is losing soil, is estimated to be 5 billion tons every year. So globally, 24 billion tons of soil are lost, of which almost 22% is from India. But India has only 2.2% of the landmass of the world. So there's a real soil emergency, water erosion, all the kind of chemicals we're putting in the agriculture. Then you know that there's loss of biodiversity, very severe loss of biodiversity, then air pollution, water pollution. Of the top, somebody was telling me, top 50 most polluted cities in the world, 33 are from India. Air pollution. All comes from variety of factors. So environmentally, there is a crisis. From the producer side, there is a crisis. Consumption side, there is a crisis. And all these crises are accelerating, and the climate change or climate emergency is just increasing. It's like you're on a treadmill. You're already sweating, but then the slope has increased and the speed has increased. So that's where we are now. So I just wanted to show one video I had sent. Resilience. Can we just first have that, and then I'll do my presentation. I had sent two videos. Did I send it to you or to? Huh? Okay, then you please go to, I'll tell you the slide number. Oh, I think I sent that to these people. Okay, just go, come down, I'll tell you. I'll tell you. Go to this and this one. This one. I just want to show one of the examples of climate change and how natural farming. Yeah, it's okay. Oh my God. No, no, it's okay. Right. No, it's not. Yeah. Recent Michong cyclone. Adjacent field. Close that. back to the first one. So you saw this adjacent fields just through a different farming practice, as one of you mentioned, adaptation, resilience. So that's the first step. At least how do you protect yourselves from? And the National Disaster Management Agency has already said that the rate at which extreme weather events are going to happen is increasing. What should have happened once in 100 years will now happen once in 10 years. What should happen once in 10 years may happen every alternate year. So the number of extreme weather events is increasing, and also the intensity of the extreme weather events is increasing. Since we were talking about climate implications, so I just thought I'll just show what is possible. And the worst thing for a farmer is to lose a crop when they are, of course, bad to lose any time. But here they are about to harvest the crop. Another 15 days, 20 days, so we have the very important festival, Sankranti, Pongal. So this happened in December. Just imagine the immensity of this loss. So I am talking about what is being done in Andhra Pradesh. Our vision is that all 60 lakh farmer households in the state and all 20 lakh landless poor families should transition to natural farming and thereby protect their livelihoods, protect health of the consumers, but also the planetary health. It has multiple objectives because, as you saw, the crisis, there are multiple crises. There is a food production crisis, consumption crisis, and environment. We need a solution which addresses all the emergencies, and addresses it quickly. You can't say, okay, I have a solution, it will work after 20 years. You can't do that. So this is our vision. I'll take you through what we have. Yeah. So where are we now? After 1 year of planning, we started the program in 2016. Just 700 villages and enrolled 40,000 farmers in the first year. Last year, we had enrolled 850,000 farmers. That means we scaled it up 20 times in 8 years. And am I blocking you? Would it be better if you sit there or? Huh? So we scaled it up 20 times. And today, 14% of farmers in Andhra Pradesh are in the transition phase, covering around 6% area. You all know that 86% farmers are small marginal farmers. Per capita, land holding is 1 hectare in the country. Not that it is all very productive land, but that much land is available per capita. And we recognize the transition of a farmer takes 3 to 5 years. Some may take more, but given the technology improvements, given the extension improvements, this transition of their, let us say, 1 hectare of land, completion of this transition takes up to 5 years. Now, during this transition, we do not provide any cash incentive, and neither do we provide cash incentive to retain them in the program, and we also don't say that we'll provide you a market premium. So these are the conditions we put on ourselves. So every state provides this cash during transition, and when they stop the project after 3 years, then farmers have reverted back to the conventional one. We also took one concept saying whole village concept. That means we enter a village, we reach out to every farmer, and this program stays in the village till all farmers change. Then the change is irreversible. We have to be there till the change becomes irreversible. So today it is the largest such program, largest program in the country in terms of farmers enrolled. It's also the world's largest program in terms of number of farmers. And it's mostly through, entirely through government funds. We also received 2 grants from Azim Premji Philanthropy and Co-Impact. It's a Washington-based philanthropy. So I'll just take you through what are those different levers which enable this scaling up. And I'm so happy that you already been oriented to the social capital generated through the mobilizing women into groups and federations. So one, of course, is a government support, because government is riding 2 horses. One is they have to continue with the chemical fertilizers, pesticides, extension system based on that. At the same time, also uh, propagate this. So the state government support is critical. The knowledge support. I'll explain to you why natural farming is different from organic farming, different from chemical agriculture, and kind of innovations we've had, and how do you take this knowledge to farmers. But these two are very important. The women self-help groups, their role is very important in convincing members to change and supporting members during the change. And then how does it go from one farmer to another farmer is the human capital. The best practicing farmers are our trainers. It's not somebody who has studied BS agriculture, MS agriculture who is telling farmers, so this person is not doing farming. So they will not believe you. Even if you are PhD in agriculture, if you are not practiced farming and then you are telling farmers to change, they won't believe. So our extension system is built on peer learning. That is, one farmer tells the other farmer. That is the strength of this program. And then a facilitating organization, in this case government, in some cases it could be NGOs. In the long run, the community-based organizations, that means the SHG federations, the panchayats, they are the ones who should hold this. And then of course, there's a lot of research happening, because what I'm going to tell you is also what is called as emerging science. A lot of knowledge is coming, new knowledge is coming around this area of work. So how do we keep ourselves abreast, and how do we also put this program to the best of science? So then I just want to tell you what is natural farming. And it's essentially mimicking nature. So it's different from chemical agriculture and also organic input based farming. I'll just explain what is the difference. But before that, I just want to know if any of you have heard of natural farming? One or two have heard. Okay. Organic farming? Every other. Okay, good. So there is a lot of similarities, but there is a very critical difference. Both are organic. That means the produce is free from chemicals. But the assumptions in the production process are different. Organic farming is also like traditional agriculture, what our forefathers used to do, right? But this is, what I'm talking about is modern agriculture. I think some of you are have science background, no? I heard somebody with chemistry, or you wanted to say something? Hurry, wait, hold your horse, I'll tell you. I'm explaining. Please wait. Okay. First I'll explain the science, and then I'll take you through what is organic farming, or even when I finish you will realize yourself. Okay. You see, life on planet Earth began with photosynthesis some 3.8 billion years ago. Life started in the oceans, the cyanobacteria. The first time the carbon from the air was split and was used for life. Life on the land mass. You're aware when life on land mass started? 430, 440 million years ago. So there's no life on Earth till just 400 million years ago. Life on ocean started much earlier. All, so whatever, it was not this flooring, but on the land mass, everything is condensed stardust. So through these 400 million years of photosynthesis, the role of the soil microbes, soil was created, greenery was created. So we are trying to say, we're going to first principles. What created life on landmass? It is the photosynthesis process. So what happens in photosynthesis? You know that in the presence of solar energy or utilizing solar energy, the leaves are able to take carbon dioxide from the air and water through the reaching them through the root system, or they're taken from the air. So they are combined and carbohydrates are produced. They're also carbohydrates, very simple form, but they can become complex carbohydrates. They're called photosynthates. You can just say food. So of the food produced by the leaf, 40% is used by the shoot system. What you can see above ground, that is called the shoot system. The stem, the trunk, the branches, leaves, flowers, fruits, that constitutes the shoot system. So 40% of the food the plant uses for the shoot system. 30% is stored in the roots. The balance 30%. That is actually pushed into the soil. That means the plant is gifting food to the soil. Why is it doing that? So this food is food for the microbes in the soil. So they take this food, they multiply, and in turn they give to the plant all the nutrients that a plant requires. We have the bacteria, the fungi. You have any idea what is the weight of these microbes below the soil? Okay, there is the weight of all living beings on the planet, living beings, is, I don't know how they estimate, but this is the figures, so I'm just repeating the figures I've got. 550 billion tons. Okay, out of which 450 billion tons is in the plants. That is the weight of all the plants, trees on our land mass. 100 billion tons belongs to the animal kingdom and microbial kingdom, out of which 93 billion tons is invisible. And human beings, so what can be seen through eyes is basically 7 billion tons. We are also part of that. Of course, we have a disproportionate influence in spoiling the rest. But we are out of that. So out of 550, 7 billion tons are the animals that you can see. Human beings, dogs, elephants, dolphins, whales. 93 billion tons is this invisible world. So essentially, this is a microbial world. All of us are just taxis for the microbes. One virus could shake the world. Yeah, you need any more evidence of that? And you also must have heard of the gut microbiome, right? So there is a soil microbiome. So this is the soil microbiome. So good soil microbiome means healthy plants, healthy microbiome in the plants, which in turn means animal health, turns means human health. So it's It's the microbiome which connects all living beings. So the food which is pushed by the plants is food for the microbes. They in turn provide to the plant all the nutrients it requires. Any of you have any idea how many nutrients are required by a plant? Yes, yes. You said NPK. 12. Okay. Anybody else? 12 micro and 6 or 17. Okay, 7. 12 plus 5, 17. Anybody else? Maybe somebody can say 18 because that's a very popular word I hear, popular number. Okay. And how many nutrients are there in a human body? We are composed of how many elements? 59. Yes. So if you get 18 from the food, where are you getting the balance? So every plant has anywhere 40, 50, 60, 70 nutrients, not just the NPK or this 18 elements. Some are required in very small quantities, parts per billion. You must have heard of selenium. Yeah, selenium is required by the body, and if you don't have, it's required in as 15 parts per billion, they say. But if you don't have selenium, you can't produce an enzyme which kills cancer cells. So like that, which element, if you have more, there's a problem. If you have less, there is a problem. So keeping this in balance is very important. So what is happening here? The microbes, because the food that the plant is pushing into the soil, the food also sends signals to the microbes related to that plant. So these microbes provide to the plant all the nutrients it requires, make it into a bioavailable form. So plant takes nutrients in multiple ways. One is in a soluble form, and that is what our great agriculture department tests. They say, okay, there's N, less N here, less phosphorus, less potassium is, yeah, what do they test? Only the available nutrient. That means what is soluble and what can be taken by the root system. But the microbial activity is to convert what is called as the fixed nutrients, not available, but fixed nutrients into bioavailable form. So therefore, the soil tests are actually useless. They don't say anything. So this is, and then the bacteria, the fungi, then they have their predators, then there are other predators. So that's how the whole thing is kept in check. So now coming back to her question. So what did Green Revolution do? In Green Revolution, the scientists said, let us take a 1 acre of rice. So when you cultivate 1 acre of rice, they then calculate how much nitrogen is in the grains, how much nitrogen is in the straw, and they come to a calculation saying 1 acre of paddy has taken away 40 kilograms of nitrogen. And then some figure, 24 kilograms of phosphorus, let us say, some 8 kilograms of potassium. So the Green Revolution said all these nutrients should be supplied. And since soil cannot get all this very quickly, you should get it through the external route. So that's how we started putting this urea, DAP, various synthetic chemicals. Organic farming or traditional agriculture believed that these inputs should come from organic forms, say cow dung, crop residue waste, or oil cakes, compost. But then what happens? You require how much? 10 tons, 20 tons to provide the same nutrients which a bag of 40 kgs will provide. So that is why that is very costly compared to chemical agriculture. Now, with this understanding, in natural farming, we are saying you don't need 1 gram of either chemical fertilizer or 1 gram of organic fertilizer. You require certain catalysts. The main food is coming from the plants. The plants are feeding the soil. Please understand that paradigm change. Then the rest of what I say will become clear. We are not feeding the uh, plant. Plants are feeding us. Plants are feeding the soil. In turn, the microbes multiply because of the food given by the plants, and then they provide the balanced nutrients. So that is why this is a very, very different system. This actually was first conceptualized in 2006 by a very famous microbiologist in USA, Elaine Ingham. She's also one of my inspiration, to, because then I started looking at it differently. Otherwise, I also thought organic agriculture, natural farming, there is no difference. So this is the difference. There is no shortage of nutrients in the soil, in the air, in water for next thousands of years. What is in short supply is the soil biology, which converts nutrients already present into plant available form, or it's like cooking it. You can't eat raw rice. So the microbes are actually cooking the rice and providing the plant an easy to eat method. So that is the basic, that's the basic science. So if you look at following natural farming, if you allow the soil biology to be activated to be optimum, then a plant gets all the nutrients it requires. But there's one more very important role for the microbes, and that is they are the best soil engineers. The microbes, starting with the bacteria, then the fungi, then all the way up to the earthworms. So the soil structure is a good quality soil should be 50% by volume. It should be air. There should be nothing in it. That's the quality of a good soil. And if you have greater carbon in the soil, you're also having greater water holding capacity in the soils. So the rain, instead of running away, actually getting into the soil, and with carbon, then it's held in the near the root zone. And obviously, with this good soil biology, carbon from the air is getting into the soil. So that's also, carbon sequestration is also one of the climate solutions. So this is what I mean by structure. You see, our soils, Indian soils are now unfortunately less than 0.3% carbon. And so soils are all non-porous and non-permeable. And if you do the biological action, what's called soil aggregation, so the soils become porous. So this is the role of the bacteria. And so you get this kind of soil. So with that kind of soil, when it rains, the water actually goes into the soil. And that water is held near the root zone because there's a good amount of carbon there. And third, which I'll explain later, is water vapor harvested for irrigation. I'll explain that later because again a very important paradigm shift. Yeah, just on the science that I've covered, if there are any doubts, I would like to clear that before I go forward. Yeah, is okay till now? Yeah, those who don't know chemistry, science, everything is fine? Okay. So now these are the principles. These are the principles which govern, and these are not man-made principles. This is something happening in nature that we are trying to understand why such a thing is happening. Now, based on the science, based on whatever we have understood, also based on some very great work which happened in India, Korea, Japan, around proponents of this. I don't know if anybody, if you have heard of Subhash Palekar. So he is, the uh, father of zero budget natural farming. Of course, he's changed the name now, but originally it was called zero budget natural farming. So, in fact, from him, he couldn't explain the full science, but he explained that you don't need organic fertilizers through he didn't call it biostimulant, but he called Jivamrita. The soil biology provides those nutrients. But now we know through science what's called as the soil food web, how it operates. So now based on the science, these are the principles which govern, this is the framework of the Andhra Pradesh community managed natural farming and why it is different. It's different from various states. So some states are only focusing on the cow. They're saying only organic products or native cow, that cow. So everything is around the biology part, the animal dung, etc. But the real force, I would say, is that once you understand that plants are feeding the soil. So therefore, if you maximize photosynthesis per unit acre, that means you are pushing more food into the soil. In turn, the soil is providing nutrients to the plants. There is a mutually beneficial relationship emerging. You can imagine these leaves to be like solar films. If you capture sunlight only 5%, what will you get? Versus if you capture 30% through good crop geometry. So that is the basic, if you want to understand with that analogy, it is how efficiently, effectively we capture sunlight. If sunlight falls on bare soil, it is damaging. So heating up the soil and oxidizing the carbon in the soil. We are emitting carbon dioxide. But the same sunlight falling on a leaf gets converted into food. So it is that simple. You are able to manage the field such a way that sun rays fall on the plants, then you are on the positive side. Otherwise, you are on the negative side. So therefore, the first principle is to keep the soil covered with living roots 365 days of the year. And the second one is very important. There should be diverse crops. It can't be that okay, you'll have only wheat or you'll have only maize or you'll have only groundnut. There should be as much crop diversity as possible. This very interesting research which happened in University of Vienna, Germany, and they've been doing this research for the last 20 years. And this is one of the conclusions of their studies, which later got replicated in Canada, New Zealand, and we are seeing the results in hundreds of thousands of farms in Andhra Pradesh. Then keep the soil covered with crop residues when the living plant is not there. If you keep the soil covered with crop residues, then you are reducing the evaporation losses and you are keeping the soil temperatures low. Soil temperatures need to be kept low, otherwise you lose the soil microbes. So many people think that by covering the soil we are providing nutrients to the plants. No, not much. The real nutrients are provided through root exudates, through the living plants, 95%. I am coming to that. You are talking about the heating, no? Yeah, I'll come to that. Then the fourth principle here is minimal disturbance of soils. And then farmers' own seeds to be used. Every agriculture department takes pride in providing new seeds, more improved seeds, university labs. Huh? Seed kit, yeah. So, and this, what I'm telling you is very interesting. This is something which has now come out as recently as 2018. A very famous scientist called James White from Rutgers University, USA. He built on a research done in Australia in 2010. But this man has been studying this for 40 years, but he got triggered by the finding in Australia in 2010. So, yeah, you're seeing this. So, there are bacteria and fungi around the root, what's called as the rhizosphere. But what scientists found is that these microbes get into the roots, called endophytes. So, the plants are so clever, they're attracting the microbes they want, take them inside, take the nutrients in the microbes and then spit them out. And of the microbes they like, which they think is important for their, not them, but their kids' survival, the seeds. So they take these microbes into the shoot. The microbes inside the shoot, the microbes inside the leaves, inside the flowers, fruits, and grain. So every seed has millions of microbes. So seeds of grains, they say somewhere around 5 billion to 10 billion microbes, but hundreds of millions of microbes. The plant is very selective. The plant is very intelligent. So it's selecting, supposing there's a plant growing in a rain-fed condition, it's very low rainfall. So then it will hunt for microbes which are, giving it properties to withstand these dry spells. And it wants to give that quality to the next generation, so it will take those microbes, put them. So therefore, farmers' own seeds, how they collect it, store it, becomes an important factor. And that is and you also heard of indigenous seeds, yeah? And you know that they are good for health. Did you ever imagine why they are good for health? These are ancient microbes. So microbes which are present some 300 years ago, which have disappeared now. So that's why these are so good for your health. So if you're eating rice, if you're eating pulses, eating maize, whatever you're eating, if you can get indigenous seeds, then that's best for your health. So it's this reason, same. Gut microbiome also likes diverse bacteria. There are some good bacteria, bad bacteria. So diversity is important. Then sixth, of course, is integrating animals into farming because crop output becomes the feed for the animals and then animal dung is used for the various biological preparations. Then the seventh is the role of biostimulants. So I'm calling it biostimulant, not as biofertilizer. So we require very small quantities. If in the traditional agriculture, 10 tons to 20 tons per acre is used, depending on the soil quality, depending on the crop that you want to grow, here you need only 500 kilograms of this biostimulant, 500 to maybe 600, 800 maximum. And after 4 or 5 years, farmers do not need this also. I met a farmer recently in Guntur. He stopped using all our Jivamrita, Gana, Drava. He said, sir, I don't need anything. My soil is very fertile. Why should I put anything? So essentially then it is plants putting food into the soil, the microbes in turn giving the plants what they require. 8 is pest management through better economical practices, and we put the ninth one in red color so that people know it's a danger. So no synthetic chemicals, fertilizers. Yeah. Yes. So let them not eat that. Let them eat their chemical food. If you place a rice made from indigenous seeds and rice made according to their recommendations, I would like to know what rice they'll eat. Huh? My guess is they'll eat the indigenous. So, yes. Yeah. Why? Who said that? No, no, any dung is fine. In Himachal, they use yak dung. We don't need fertilizers, no. I said we are using them as stimulants, biostimulants. In some countries like Korea, for instance, they don't use dung. They use some poultry manure, they use food waste, and then they use the potato, cooked potato as the base, and then they ferment all this. Different countries have different systems. Seaweed extract is used as for fermentation, compost teas.
Farmyard manure and this thing is very scarcity in the villages. So
Sorry?
scarcity in
Ah,
the villages like a
you
farmyard.
don't require much here, I told you. If you, in the traditional agriculture, if you required 10 tons per acre, now you need only 500 kilograms. Ah.
For organic certification, only the soil is tested. But what is preventing from getting approval for a natural farming with the
No, no, it's not just soil test, they test the residue on the crop, on, if it's a grain. Yeah, so they test both. But I am now disputing, the soil testing is not required because the plants do the filtration. No, you call it organic farming, I have no problem. I am saying the output is free from chemicals, right? So that is the definition of organic. But organic is not looking into what is the nutrition in that crop. So we are now doing this testing of, we've done lots of rice we have tested. We now want to test fruits, vegetables. Under natural farming, what is the nutrition composition of these fruits, vegetables, grains? So the organic, meaning of organic is currently that the product is free from synthetic chemicals. Whether it's natural farming or organic input farming, it will be free from synthetic. It could be. But it needs to be tested. Yeah. See, it's like, earlier, supposing you buy milk. So in the villages, they naturally mix water. Otherwise, that fellow thinks that he's not doing dharma. So, but now, once Amul came, so they have this, density testing, the lactometers. So then the farmer gets paid not for a white liquid, but for the fat content, for the SNF. Exactly. So that measure, now today, if you see a tomato, you have no way of knowing what is the nutrition in the tomato, right? You just know that, okay, there's no chemical, so you have to buy that. That's even worse. So, yeah, that's why it doesn't look different, no. But the shelf life will be different. Our shelf life of a natural farming tomato could be 2 weeks, 3 weeks. Nothing will happen if you don't keep in the fridge. You asked? Ah, okay, sorry, yeah. Ah. No, wait, it's coming. Ah. Different people take different amounts of time. Most important is, for the wife to convince the husband. That's the biggest battle. She has heard in the women's self-help group that natural farming is good. And she goes and tells in the house. This fellow will say, what do you know? We've been doing this chemical agriculture. But thanks to the knowledge or strength she gets from the women's self-help group, she doesn't give up. So then they decide, okay, this is a piece of land. You do in this small portion, you do your way, I'll do in my way. I asked many women how much time it took to change your husband. So from 1 season to 3 years. For 3 years, the fellow didn't change. Third year, his crop got there. affected by disease he could control. So then finally he told her, okay, you are one. It took him 3 years. So now we selected her as our farmer scientist. So different things, father doesn't want to do it, son wants to do it. The most difficult battle is within the household. Brothers, I've seen, you saw that Michong cyclone, right? This farmer who is standing, I asked this fellow, I went to that village. I asked him, your crop is lost? Yes, sir, lost. The neighboring crop? No, sir, it's very good. In fact, they got a higher yield, Subbu, in spite of the cyclone. They got a higher yield this year. So I told him, why didn't you listen to me? Sir, he's been seeing that for 3 years, Mr. Vijay. And he says, I laughed at them when they did that. Now, who's laughing at you? So these are behavior change issues. And that is why the women's self-help groups, that's why when I showed the levers, when I come to discussing the levers, I'll tell you. But this is what it takes. It takes time. It's not just the understanding. See, they all know that the present system is bad. On that, I have no problem. They all know, yes, sir, this is bad. But what is the alternative? For that to understand and change takes time. Yeah. Yes, yes. Yeah. They're risking it, no? No, I got close to 10 lakh this year. This year I'll touch 10 lakh farmers. I've already touched 10 lakh farmers. Changing. So those were the heroes who changed. So I had to really, they are my gurus. So they changed. Whatever reasons, I'll give you one very strange reason. You won't believe it also. I went to a village, this old farmer, I asked him why he changed. He said 2 years ago, his dog stopped eating the rice he gave it. So he used to mix it with milk, it won't eat. So then he had to put rasam or something to hide the smell. Then when he heard about natural farming and what it does, then he said, I am eating the rice which my dog refused to eat. So then he said, okay, whether I make a profit or loss, I'll change. So there are very different reasons for change. One, they're all fed up. Farmers everywhere know that their costs have gone up. They're looking for alternate everywhere. So that is what ICAR has done. At least all the farmers are fed up. That is a good point actually. The farmers are fed up, but the alternative is what is the difficult part. It doesn't take much time.
Like farmers used to say when we shift to the natural farming, they are not getting a more yield.
I told you just wait. Wait for that. If our women's organization is FPO, no? This FPO is a new concept. It'll take another 20 years to stabilize. Somebody says let there be 10,000 FPOs, let there be 20,000 FPOs. I don't have much faith in these FPOs if they are not built properly. Just come up because to get money from the government. I don't want to. For me, my women's organization is an FPO. They already invested me, Subramaniam, my predecessor Rajshekhar, no, my successor Rajshekhar, my predecessor Raj. We have spent how many years? 30 years now building the SHG movement. I don't want to spend another 30 years building the FPO movement. The women are doing the work. Why should I again get another institution? Yeah. Yes. Ah.
Comparatively less, and it gets dissolved easily.
Ah.
So that and say for example in a country like India, it's only not like Europe and other countries. So such chemicals are not.
We'll ask them to only eat this food. No. We'll ask them if you have this food versus organic food, which food? You should not be hypocritical. You eat that food. The first test to anybody who says that. I used to scold my university professors. You want to eat organic food, and then you are saying that, this chemical food should be grown. Yeah, so farmers know that, this is good food, let others die. I scold them for that also. That means you want to live, others should die. So I have a different. Ah, that's right. Yeah, yeah. They're also to blame. Ah, ah.
Popular beliefs, natural farming is not such a good thing, and it was okay in Kerala, it was reported widely also.
Saying what? Natural farming is?
Natural farming, right, and that is Michigan yield to benefits. It was said in an event conducted
Which year? Oh, okay. He has not said that. I've heard him so many times.
I brought him in 2008.
But Baba, I brought him. Listen, the first training program he conducted for me in 2007. But science is science, brother. See.
All the agricultural. But he is a very funny.
I know. That's right. Yeah. That's why people find it difficult. Yes, you had something. Between, I already explained, no? Organic farming means,
External inputs.
yeah.
Soil balance.
Ah, yeah. This part. They use tremendous quantities. They use huge quantities of organic inputs, and they don't do enough of these two. See, 1 and 2 they don't do. It's like monocropping. It's like you don't change anything. It is monocropping only. Instead of synthetic fertilizers, you are putting organic. Okay. Yeah.
What you taught
Uh,
says historically we have been spending a lot of time on soil physics and soil chemistry.
yes.
Soil physics to keep the fundamental.
Right.
Soil chemistry, all the now we shift the soil, but
Yeah.
that's a big shift. So to understand it very clearly, can you see?
So you see, yeah, this they don't do. In fact, Mr. Sunita Narayan had come. He said, Vijay, when I came, I expected it will be like any other organic that I have seen. But here you've got crop diversity, 365 days, green cover. He says, this simply blew my mind. Huh? Correct. And producing enough on the ground.
You don't budget things. You will produce so many things that then we don't make.
Yeah.
But that is not a question. There are some costs. So when you talk of diverse crops,
Yes. Yes. No, same. Cereal also. Huh? Yeah.
also diversity. Periods like one crop you take up, maybe another crop you take up, brand, third crop you take up something else.
Right.
Or it could be that all 3, 4 crops you take at one.
No. I'll tell you, paddy is my biggest problem. Because paddy, you can't grow anything inside paddy. So let's keep paddy aside for the time being. Let us take cotton. So cotton typically, and now in Maharashtra and all this high density cotton aa gaya, wo beej zyada bechna chahte hain. They want to sell more seeds. So they're telling the farmers to plant more cotton plants, Mr. Vijayan. Normally it is 1 kilogram per acre. I don't know what these high density fellows are doing. We are telling the farmers to plant cotton at distance of 5 feet. In between there is a jawar or a maize crop. And then there are 2 pulse crops. And then on the borders, there will be 1, 2, 3. Then, 1 second. After cotton is harvested also, even in dry lands, we take another crop. That I'll explain. And before, of course, cotton generally is sown at the time of monsoons, but we have something during when the cotton is there, and even in rain-fed lands when cotton is not there. Because now we are growing cotton trees also. That's a separate story. It's being experimented. So there's no need for sowing seed every year. So, but we have other crop. So 365 days green cover needs to be maintained. Yeah, if you have irrigation, but suppose you require very little water. But I'm saying it works even if you don't have irrigation. Yeah. 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 Uh, uh. No, see, in the plant, trees are growing up. You have to see where is the root zone. So based on the root zone only, you should do the water application. It's recommended, but where the root zone is. The drip irrigation right now, what is doing is putting water in the wrong place. Yeah, that's right, exactly. Yeah, yeah. So you have to see where the feeder roots are, and that's where the watering should be done. And that portion between the trees, our emphasis on covering that with other crops. Even in mature orchards. So we have some plants in the canopy under the shade, and then some crops between the. But this is a very difficult part to change the farmers. So they've been told you have only one crop, the orchard should be neat, you shouldn't have any because it will also take water. So, but this is the difficult part. No, no. So I told you that plants feed the soil, right? I'll also tell you that plants produce water. So, so that answers your question also. How the cooling happens and plants. So, okay, so these are the principles. Yeah, and as you can see, these principles are arranged around maximization of photosynthesis. Then helping the soil biology. And then finally around the seed. And then you have the biostimulants, and that is what is unique to India. Concept of very systematically application of these biostimulants in different stages of the crop. So which I'll explain now. Which one? Yeah. Now see, weeding also is a sign that your soil is dominated by bacteria. So weed is a grass. So if see what is called as fungal bacterial ratio. So if in a bacterial dominated soils, you will have weeds. So if you over a period of time improve through all these practices, farmers are reporting less weeds. Weeding to करना पड़ता है. But then keep it on the ground after you don't remove the weeds. Ah, I know that is the most criminal aspect of these all these companies. That's the most dangerous thing. Oh, yeah. So in paddy, for instance, if you have azolla, you will not require any weeding to be done. And uh, that's very dangerous. I know that. Yeah. I know, but it kills everything else. It kills everything else. Yeah, that's right. Yeah. So this is crop diversity, and this is our first, in the biostimulants, the first one is seed coating. So it's a bit of cow dung, cow urine, lime, bit of soil and water. It's fermented. Ah. You get cows. What is there? What is so difficult in getting cows? Yeah. See, no, we did a lot of research. We did with indigenous cows. We did with hybrid cows. We did with buffaloes, sheep, and goats and bulls. So native cows, to give credit to Palekar, turned out to be better from the science point of view also. But it's not as if the others were not doing. It also depends on what you feed them. If something is if it's a indigenous cow, you just allow it to graze wherever. There's no management. So it's all actually eating healthy in terms of the microbiome of the dung. But if you have a hybrid animal, then you'll be putting the feed and you're not allowing it to graze. So that causes its own changes in the microbiome. But you can use any cattle. It's not required that you should have only cows. You can use buffalo, anything. Yeah, any cattle. Because what is interesting is the cattle, they're called ungulates, hoofed animals. The camel, the deer, the cows, the kangaroo, yaks, hoofed, yeah, that's right. Ah, correct. So they all evolved at the same time as grasses evolved. So 100, 120, 110 million years ago. So they are a mechanism to control fire. So in the hot summer, if they have not eaten and converted to dung, then the place will be on fire every year. So that's how there's a co-evolution. So if they are evolved together, then obviously, any dung is good. But we tell the farmers, you test yourself. If, like they're asking me in the Northeast that we have only pigs, we're working in Meghalaya or Nagaland. So then I asked him, you experiment with the pig dung. We don't have pigs, so we're not doing any experiment, but you can try it. Huh? Pigs. Pigs are also ungulates. So any hoofed animal. So this is a seed treatment which provides the bacterial and fungal coating to the seed. So now you understand there are microbes inside the seed. So with this seed coating, we are establishing a communication between the microbes on the seed, microbes inside the seed. And when we plant it, we're also giving a biological inoculum when we are sowing it. So the seed knows it's in a very good microbial environment. This is a soil amendment. It's called Ghana Jivamrita. So it's cow dung, cow urine, jaggery. Jaggery is to sucrose, provide sucrose to the microbes, pulse flour. This can be kept for about 6 months, air dried and then powdered and applied along with the seed. Which one? No, it has to be fermented for 7 days. Yeah. Shade dry them. Oh, they can in this step 2. Yeah, they first mix them thoroughly, and then यहाँ पर ये then they dry it in the shade. 7 दिन लगता है. 7 दिन they have to be fermented for 7 days. Just left under shade. No, you powder it. So when you're wherever you want to open, that's a different thing. This is the Bijamrita. So you have cow dung fermented for 12 hours. Then it's squeezed in water, yes. In water. And then you squeeze so that all the fermented portion comes into the water. Then you mix cow urine into that. And then a bit of lime and sprinkle it on the seed. Just throw it out. It's not much. It's just require about 2 kgs per acre. It can be used. I mean, but I mean, from the purpose of seed coating, it doesn't serve any purpose. Here, just before sowing the seed, you need to do this. This is to be done just before sowing the seed. Which one? No, you don't need to dry. You just uh, put the seed in the soil. But you don't soak it. You just sprinkle it. It's not soaked in this. So this is the seed treatment, the first one. Then this is soil amendment. You see this once after 7 days, then it is powdered. And then when you are sowing the seed, you also put the powder into the soil at the same time. Then once the plant germinates, once the plant has germinated, 15-20 days after germination, you have this liquid inoculum. It's again cow dung, cow urine, pulses flour, jaggery, water, and a bit of uncontaminated soil. That means microbes in the soil, microbes in the urine, microbes in the dung, they all get mixed, multiplied, and then they are available to be sprayed. This is the botanical pesticide application. This is a neem astra. You know, they're preparing a based on the neem leaves. Oh, this is soaked in cow urine for about 48 hours. So it's not you have neem seed kernel extract. That is different. Yeah. In the cow urine for about 48 hours. And then whatever is the liquid that gets, pulverize it in some cases. Otherwise, they just take the leaf. They can be used as a part of, yeah, you have to crush the leaf. Then only it makes sense. So we have videos of all these. Of course, they are in Telugu. We are also trying to make it in Hindi. So all these applications, we have 6 to 8 minute videos, which explain to the farmers step by step how this is done. Yeah, this is something very new. This is started only 2 years ago. This is called seed pelletization. So this, eliminates the dependence on rains. Otherwise, in a place like Anantapur or any other drought-prone districts, unless you have 30 millimeters of rainfall, the ICAR scientists will say that you cannot do land preparation. After that, within 2 weeks, another 30 mm rainfall should come. So you never have those kind of situations. I know. Yeah, I know. That's right. Yeah. So what we are doing here is sowing these pelleted seeds in dry soil. So with very little water, the germination happens. So this is a very important innovation. And so that is about the different practices. So this is the role of the women self-help in this whole program. So we have in these villages that we are working, close to 20 lakh women are in the self-help group in these villages. So broadly 60% of them have lands. So the main livelihoods is farming. They means they and their families. 10% non-farm livelihoods. 30% are landless farm workers. So we have a intervention. So even for the landless farm workers, we have an intervention which I'll explain. So the women self-help groups, they discuss these things. They finance members, requirement for transition. Somebody wants to buy a cow, somebody wants to invest in land development, or somebody wants to construct a cattle shed. So whatever investment is required is financed by the women self-help groups. Again, from the project, we are not giving any money for farmers transition. But the women review this program, they do the planning, So this is really one of the most important pillars on how we could scale it up so quickly. And this is how does that knowledge go to other farmers? So this knowledge goes through champion farmers. So the best practicing farmers are then designated as farmer trainers. It takes us 3 to 4 years to develop one such trainer because they have to practice it well first. Then only others will believe in them. So this is again a very important part of our entire investment in the project is on building their capacities, paying remuneration to them, then going and verifying their, yeah. Yeah, green cover. Yeah. Yeah. That I'll just show you a video. Just hold your horse on that. That's the most important factor. That's what is the solution for the drought prone areas of the country. Which district? Ah, okay, please do that. Yeah. Uh-huh.
Said that pick up 1 or 2 villages, 1 or 2 farmers, and demonstrate that it can be done in irrigated area.
See, irrigated areas, there's no problem. The problem is basically in the rain-fed areas. Oh, okay. I get your point. Yeah. Then some little water can be provided there, right? So this is the way knowledge is taken to farmers. So the 1 per 100 farmers, more than 50% are women. The trainers are women. And use of ICT. You see that video there? So whatever I've told you, all these practices are in video form. So everything, whatever interventions we have, they're all in training video format. This is to show it takes time for this transition. So this is a individual farmer's journey, starting with convincing the husband maybe year 1 or year 2. So that will I found 100% the women wins. Then they expand the area, etc. Then in the village also, not everybody will come in the first year. So small number will come, more number, greater number. So therefore, I said it takes 8, 10, 12 years in one village to bring about a change. So that, it depends on the pruning is very important. So then that really depends on the genius of the farmers. What is the right amount of light to be left for the understory? Yeah. No, I had a ADG of ICAR only telling me this. So he came. But then the farmers' incomes went up more than 3 times. We have, so this banana, you see, for 6 months, farmers take intercrops in banana. From 7th month onwards, the canopy cover. So the 6 months income is more than enough for all the costs. And then the banana yields are much higher after this. And the water requirement comes down. But the crop geometry is something which needs to be played with. There is no one, so there is no top-down prescription. So people have to burn their fingers, try this, try that, and then come to a solution. This is also part of this learning curve. Yeah. Oh, that one field they said that for 3 years. That the first field. The second field that lady had been doing it for 5 years. But we find we get the results in the first year itself. It doesn't take that much time. So if you're not harming the soil, obviously it will flourish, right? So even if one day you don't harm, then the next day the soil will be happy. Sorry. Over now, 5 minutes. Hmm? Yeah. So we also have another meeting now. My God. So Suvarnam, you told me to take my own time. That's why he got distracted. So I was at 45 minutes. Okay, this I'll leave behind. It shows there is no yield penalty. People are asking what happens to production. So this is these are the yields, right? So yields are higher in natural farming. So very large samples, very large number of samples. Natural farming, community managed natural farming, APCNF, Andhra Pradesh community managed natural farming. We used to call it zero budget natural farming. We changed the name. That was the earlier SERP. We started with NPM. Yeah. So you can see here the yields are higher. And now this year, with all our practices, we are finding in the first year itself, farmers are getting similar yields or higher yields. So our technology is also changing. This is the average age of this farmers is 2.2 years. 2.2 we have mentioned here. Because we ask those farmers who have stopped chemicals, we list them out separately. So then randomly they are picked up for this measurement. Yes, yes. Yes, absolutely. That's right. I was having a meeting with the Secretary of Water Resources on this. Then this is the Rabi crop. Then okay, biodiversity. Yeah. So this is our experiments on water. So up to 50% crop water is reduced. That's right. Yes. This is what we did in 2021. Now we have two independent studies, ASCII Core Carbon X and Valamtari. They are doing these studies now to see the no on Telangana. Groundwater. Okay, I have time. I'll sit with Sitaram. No, I have to sit with him. This you saw. Now this is the desert, which is the first year of greening. They're getting a crop. So the most degraded lands also can be brought to life. You can see here the soil this is the contrast. That is the kind of soil, this is like sand, it's just like desert situation. This is what we were requested by a sheikh from Sharjah. So he's come and seen this, so he'll be twinning this village with Sharjah. Where? Yeah. Correct. And also to finish the class now. We'll discuss about to finish the class now. Right. So Mr. Subramanian has issued a rule, issued an order. So this is the reduction in pesticides or resilience to pest attack. This is for the landless farm workers, homestead gardens. Okay. Subha, I have to show this video and then we'll So the water question has to be answered. That's a big technology breakthrough. Can you play that second video? So your question about what to do where there is no water. So this is a solution. In material means I already kept it here only. It's in your system. Oh, it's there. APCNF channels. Anybody wants any kind of videos, we can supply. We made some of them in Hindi also. Yeah, the first one, first. Yeah, that's right. Full screen. So this is in a rain-fed land where maize was sown in the month of January without irrigation. So naturally, this was shot in the month of April 2023. Manually, just 1 acre of land. Manually, yes. Yeah. That manually it could be a bullock cart or even hand drawn. So you can see in the horizon there are no crops anywhere. Yeah, no crops anywhere except if there is some irrigation. Even irrigation, they didn't dare to take a crop. So this is maize, but with plenty of intercrops. Tomatoes, beans, field beans. Yeah, you can see this. Totally green. Of course, the farmer had harvested earlier a lot of picks of tomatoes. And you can see the beans, field beans. Yeah, so for pest control, you saw the botanical pesticides, but now we have gone a step forward. We are saying pests also should live. They should also eat. When the pests are there, the predators will come. So we have what are called as 20, 30 different biodiversity crops, which we broadcast. You will see in this field also, there is some this marigold here, marigold, there is some sesamum, there is some castor, there is some bindi. Bindi also attracts a lot of pests. So if you have this 20, 25 different crops, so the pest load is kept to a minimum. Pests are required, otherwise you won't get the taste of that vegetable if there is no pest attack. No, that's science. So they're saying grapes are sweet only if there is a pest attack. So the pest attack stimulates the plant to produce these phytochemicals, antioxidants. It is to fight pests. So there's a need. So yeah, can we go back to the presentation? Quick. So this was in the month of December when the previous crop of groundnut was harvested. Then with this pelleting, seed pelleting, so this farmer could take this crop. So this is basically, now it comes to the water vapor question. If you have a green cover, then I don't know how many of you are aware that there is 50,000 parts per million of water in the air. That means 10 rivers of water are flying over your head at all times. So through natural farming, we are saying, can I take a few drops every day? And that is the experiment we did in 2018, which was successful. And that has given us so many game-changing solutions. So this is Walter Yana, a scientist from Australia who inspired us to do this. And then he came to see this and he has given us, he's been mentoring us. Actually, we have a team from Australia right now doing some experiments and making a film of this. So then he said there is one season before the actual monsoon. So we call it the pre-monsoon dry sowing. So we're not allowing that March, April, May to go waste. So there is some green cover. And then another crop they take. So this is what we are doing for, we are creating A-grade farmers in every village. Not everybody is doing it. We have about 10,000, 15,000 farmers in Anantapur who are doing this. And another 2 years, we want to create 60,000 farmers all over the state with this concept that they should take 3 crops in a year, even in rain-fed conditions. And this in turn is, like this is a cotton crop with intercrops, so cowpea, pearl millet, and cluster bean. And also in between there is green gram, okra, and castor. So the spacing is 5 feet. So the cotton yields also go up and the farmers are getting this intercrop. And they also have this 25 biodiversity crops. So the question about pest management. Pest management is actually happening now automatically. The pests are eating something, the predators come in chase of this pest. And cotton has now become a perennial crop. Farmers are harvesting, returning it, and then taking another cotton crop. So this is again banana, intercrops in banana for about 6 months, and which has increased their yields tremendously. This is, one of our farmers with groundnuts. We have a new model, we call this the ATM model. This is for the landless poor, very small farmers, 800 square meters, 1/5 of an acre, where you have 15, 18 crops. And Mr. Vijayanand, you can earn between 10,000 to 20,000 rupees per month. Yes, that's why it's become going viral, the ATM model. And very little water, once in 15 days, once in 20 days, sometimes once a month. And you can see, and there is some sequence, the tubers, pulses, green leafy vegetables. So they are also doing it in the mango orchard with the result that the mango yields are going up. This is a drought proofing model which was triggered by the El Nino last year. So this is a August 2023 innovation. So without plowing the land. So we are saying even in degraded soils. So we have these crops. So there is castor, red gram, hardy species of crops. And this lady has got income from that, she was not expecting. There are all the scientific institutions who are working with us. These are the international institutions. We also now have ICAR. ICAR institutions are, I'm funding them now to do research, but not in their research stations, in the farmers' fields. During tea, not now, no, I just quickly run. I got an order from Mr. Subramanian. So this is the latest one. We thought why we should respect only ICAR scientists, why don't we respect our own farmer scientists? So we are now developing one farmer scientist for every village. It's a 4-year course, but the condition for graduation is not passing the examinations. Conditions for graduation is they are earning 25,000 rupees per month from farming. And among them, distinction marks to those who earn 50,000 rupees per month. So that is the graduation condition. Of course, 1 week classroom, 3 weeks in their own. About 45 countries have come to see our work. Many of them want technical support. And these are the states where we are working in India. So we have the first state we started work was Madhya Pradesh. So we started in Mandla, Vichya block. But now Madhya Pradesh government has asked us to start in every district, one block in every district. So we started 7, 8 districts, and now we will be sending people for other. Then Meghalaya, we are there in every block, one block per district, and then Rajasthan. And in the remaining states, we have a project with NABARD and GIZ. So where we are incubating this natural farming methods in these states. And hopefully after elections, maybe Telangana, Karnataka, Jharkhand, Kerala, of course, I have ruled out, but I ever optimistic. So at least 4, 5 states are planning to enter into MOUs with us. That's the reason why I need time with Chris. So this I'll skip all this. I'll go to, yeah, this is your question, Subramaniam. So you see this soil is bare. It's re-radiating heat. And that soil temperature is very hot, 60, 70 degrees centigrade. But if you have 365 days green cover, you are cooling the soil. So once you are cooling the soil, there is less heat radiated. So then you are having a very different cooling mechanism. So I was in Germany recently. So the Potsdam Institute of Climate Change, one of the most respected institutions, they'll be working with us to calibrate this as a model. I'll read this out. We do not inherit the earth from our ancestors, we borrow it from our children. So that is something to stay in your mind. It's a, I got it from, they said, American Indian proverb. Yeah?
He said air, water, earth.
Ah.
We don't inherit from our
Yeah?
father.
Fantastic. Okay, I didn't know this. Yeah. So thank you, Mr. Subramaniam, for driving me right from morning to evening. Okay.